friends, in this video we will study about the flow rate measuring device known as rotameters. Rotameters are also known as the variable area meters. So in this video we will study about its principle of working, its construction, its applications together with its advantages and disadvantages. So let us start with our topic. Rotameters, they are the devices which are used for the measurement of flow rate. So they are used as the flow meters, means for the measurement of the flow of either liquids or gases in a closed tube. So if a liquid is flowing in a pipe, then the rotameters, they are used for the measurement of the flow rate of the liquids, and if the gases are flowing in the pipe, then it is used for the measurement of flow rate of gases also. So for both liquids and gases flow rate measurement, the rotameters are used. So rotameters, they are invented by the scientist Carl Kuipers, and since then they are being widely used for the measurement of flow rate. Now the rotameters, they come under the category or under the class of devices which are known as the variable area meters. So rotameter is also known as a type of variable area meter where the flow rate is measured by measuring the change in the cross-sectional area of a tube. So because flow rate is measured indirectly, means by measuring the the change in the cross section, so they are known as the variable area meter. So rotameters, they measure the flow rate by measuring the change in the cross sectional area. In rotameters there is a tapered tube. Tapered tube means a tube which is having a wider opening and a narrow closing. Okay, so at the top of the tube it is widened, and at the bottom the tube is having a very narrow opening. So the shape of the tube is tapered. So a tapered tube is used, and in that tapered tube, as the fluid starts flowing, the cross-sectional area of the tube also gradually increases. Okay, so the change in the cross-sectional area of the tube is used to measure the flow rate of the fluid flowing in the pipe. Okay, so that is the basic principle on which the rotameters work. Now, as I have said that in rotameters, the flow rate is measured by measuring the change in the cross-sectional area, and the change in cross-sectional area is occurring because the fluid is flowing in the pipe. Okay, now what this fluid is causing, and what is the cause of the change in the cross-sectional area? The flow rate inside the rotameters, it is measured using a float. So in rotameters, we are having a taper tube, and in that tube we are having a float. So as the fluid starts flowing, the float also rises up in the tube. Okay, as the float rises up, so this float is not going to, this float is lifted up because based on the buoyancy and velocity of the fluid, which is opposing the gravity, and gravity is pulling the float down. So fluid, due to the flow of the fluid, the float starts rising up, and due to the rising up of the float, the change in the cross sectional area is occurring. So the rate of flow is proportional to the change in the cross sectional area. So in this way, in rotameters, due to the movement of the float, or due to the rising up or falling of the float, the change in the cross sectional area is occurring, and that change in cross sectional area is proportional to the flow rate of the fluid. Now the float is rising up in the tube. So on this float, two forces are acting. One is the gravity that is acting in the downward direction and pulling the float in the downward direction, but the fluid flow is trying to raise up the float. So two forces are acting, one in the upward direction and one in the downward direction. So at the position where both these forces are equal, the float is going to come in a steady state. So because the gravity is acting on the flow, so sometimes these rotameters, they are also known as the gravity flow meters. And why they are known as the gravity flow meters? Because the gravity is acting as the opposition force trying to pull the float in the downward direction. So they are known as gravity flow meters because they are based on the fact that gravity is opposing the rising up of the float, and the upward force acting, that is the fluid flow, it is trying to raise the float. So there is an opposition between these two forces, opposition between the downward force of gravity and the upward force of the flowing fluid. Okay. Now the position where these two forces, upward force and the downward force, they are equal, at that position the float is going to come at the rest position or steady state, and that position can be measured with the help of a calibrated scale. So when the flow of the fluid is constant, means when both the forces are equal, then the float stays in one position, and that position can be related to the volumetric flow rate, and that position is indicated on a graduated scale. So here one thing we have to keep in mind, that to keep the full force of gravity active on this float or working on the float, the dynamic balancing should be there, and for the dynamic balancing, the tube, Okay, so there must be a vertical measuring tube which should be in a tapered position so that there is a change in the cross sectional area. Tapered is used because if a straight tube will be used like this, and if float is present here, so when fluid is flowing here, it is going to lift the float upwards, and there will be no change in the cross sectional area. Okay, the cross sectional area, that is this area, will remains the same when the float is rising up or falling down. But if the tube is tapered and float is suppose present here and fluid flow is trying to raise up, so when this fluid is raising the float, a change in the cross sectional area is occurring. Here the area is different, here the area is different. So that is why in the rotameters a tapered tube is used. Okay, but this tube should be kept in the vertical position so that the gravity can act on it. Okay, and a dynamic balancing will be there between the upward force and the downward force. So this was the principle of working of the rotameters, that how they measures the flow rate by measuring the change in the cross sectional area. Now here, as the flow rate is not measured directly, it is measured indirectly by measuring the change in cross sectional area. So rotameter, we can say that it is an indirect method of flow rate measurement, where the scale is not giving us the direct readings of flow rate, but it is giving an indication of the change in the cross sectional area. Okay, so level is the flow is not indicated by the scale, but a different quantity is indicated, so it is an indirect method of flow rate measurement. Now let's see the construction of rotameters. So we have seen here that the rotameter, it consists of two main parts. One is the tapered tube, which is made up of glass, and a float, which is generally spherical in shape, and it can be made up of stainless steel, metals, or ceramics. Okay, the shape is generally spherical so that when the fluid is rising up, it can easily raise the float. Now we have studied the material of which the float is made up of. We have studied its shape, that it is spherical in shape. Now this float, it should be made up of material which or this float, it should be denser than the substance it is resting in. Okay, so suppose that we are having the water as the fluid, we want to measure the flow rate of the water flowing in a pipe, and the float, it should be denser than the water so that it does not sinks in water but it floats on the surface. It does not floats on the surface of water, but it floats somewhere between the surface and the bottom of the container. Okay, so float is just not on the top of the surface of the liquid, but it is somewhere between the surface of the fluid and the bottom of the container. So it should be made up of a material which is denser than the fluid whose flow rate we want to measure. Okay, now let's see the diagram for the rotameters. So this is the diagram for the rotameters. You can see it consists of a tapered glass tube, and in this glass tube we are having the float. Okay, now this float, on this float, when the fluid starts flowing, okay, it is somewhat like in this bent shape from downwards. So from here the fluid starts flowing in it. So when the fluid flows, there is an upward force acting on this float, due to which the float rises up in this tube. Okay, now on this float the gravity is also acting, and this gravity will try to pull the float downwards. Now this float will come at an equilibrium position when the gravity and the flow, both the upward and the downward forces acting on this float, they are equal. So it will come to the rest position or the equilibrium position where the two forces are equal, and we can read its position on a graduated scale. So when the float is downwards, means when the fluid is not flowing, the float will be at the bottom of the tube. Okay, so at that position we can measure its position with the help of the scale. Now as the fluid starts flowing, the float also rises up, so there will be a different position. So that position can also be measured with the help of the scale. So area is also changing, because at the bottom the area is narrow, but when in the middle the area will be more. So there will be a change in the cross sectional area. So that cross sectional area, the change in cross sectional area will be proportional to the rate at which the fluid is flowing. Okay, so in this way it is going to measure the flow rate. So that was the construct. So as the liquid or the gas, it passes through the tube, the flow of the liquid or gas causes the float to rise. So we can measure a precise value of the flow rate by measuring the position where the float is resting. Okay. So that was all about the construction and the working of the rotameters. Now let's derive the equation through which we can measure the flow rate and through which we can get that the change in cross-sectional area is proportional to the flow rate. Okay. So as in the rotameters, a tapered tube is used. So we have seen the shape of the tapered tube, that in that tube the cross-sectional area or its diameter is increasing gradually. So due to the increase in the diameter of the tube, the area around the float, the annular area around the float is also increasing. And this tapered tube, it is going to follow the volumetric flow rate equation, and that equation is Q equals to K A under root of G H, where Q is the flow rate, the volumetric flow rate, K is a constant, A is the annular area between the float and the wall of the tube. G is the force of gravity, and H is the pressure head. So from this equation you can see that K is a constant, acceleration due to gravity is also a constant, and in the rotameters there is no change in pressure. Okay, so pressure head is constant also. So this flow rate, volumetric flow rate, it is directly proportional to the annular area. So we can say that as the area is changing, the volumetric flow rate is also changing, or if flow rate is changing, the area is also changing. So by measuring the change in the cross-sectional area, we can measure the flow rate of the fluids. So this was the equation on the basis of which the rotameters work, and they measure the flow rate. Now comes the advantages of the rotameters. So some of the advantages of the rotameters is that they are very easy to construct. They are made from inexpensive materials. They do not require any external force except the substance which is used to measure the flow rate. And also they are used in a wide variety of systems due to their portability and small design. Also, The rotameters can be installed in areas with no power, because as I have said that they do not require any external force. So the power which is required for their operation, that is provided by the fluid only. Okay, so the fluid whose flow rate we want to measure, that substance is providing the internal power for its operation. Also, the rotameters, they can be installed with the standard pipe fitting, so no modifications are required. And if the rotameter is properly maintained, then such type of rotameter is going to provide the operator a very high repeatability. Also, the range of flow rate measurement is also very high. So a wide rangeability is provided. Also, the rotameter scale is linear, so no non-linearity problem is also there. The flow rate is linearly varying with the change in the area, so its scale is a linear scale. Also, pressure loss due to rotameters is minimum. So these are some of the advantages of the variable area meters or the rotameters. Next come its disadvantages. As in rotameters, the gravity is playing a very important role, because gravity is pulling the float downwards, and fluid flow is causing it to move in the upward direction. So the rotameters, they must be installed vertically with the fluid flowing up through it. Okay, so when the fluid is flowing in the upward direction, gravity is pulling the float in the downward direction. So rotameter should be kept in the vertical position, with the fluid entering in it from the downward direction from the bottom, and so that the float can be raised up with the fluid flowing. Okay. Also, it is difficult for rotameters to adapt for the machine readings, although in some of these cases the magnetic type of floats can be used. So the graduated scale, which is used for the measurement of the flow rate or for studying the position of the float, that graduated scale is valid only for the specific fluid and conditions where it was calibrated. So this scale has to be calibrated again and again for the specific setup or for the specific fluid and the conditions. So for every time we are using a different fluid, every time we have to change the setup of the graduated scale. We have to calibrate it again. Okay. So again and again. So again and again calibration has to be done for this graduated scale. So that is a disadvantage. Now rotameters, because the tube, it is made up of the transparent material, glass material, so that the operator can see the movement of the float. So this transparent material, the fluid which is whose flow rate we want to measure, so we have to check the chemical compatibility of that fluid with the transparent material so that no damage can occur. Okay, so for every fluid, before the doing any type of measurement, so before doing any measurement, we have to check the compatibility of that fluid, chemical compatibility with the transparent material or the material of which the rotameter tube is made of. So these are the disadvantages of the rotameters. Now comes its applications. So rotameters are used to measure the flow rate in systems where the liquid or a gas is flowing through a pipe or a tube. In water plants, in wastewater plants, it can be used to measure the flow rate. Okay. Portable rotameters can also be constructed for which are used to measure the flow rate of the large bodies of liquids or gases, like liquids. In liquids we have the river, the oceans, and in gases we have the atmosphere. So for the large amount of liquids and gases, the portable rotameters can be used. So when we are measuring with the help of the portable rotameters in these large bodies of liquids or gases, so simply these portable rotameters, they are dunked into the substance, they are placed into that substance, and the measurement can be done with that. Okay. So these are the applications. We have seen that rotameters, they are used for the flow rate measurement of liquids as well as gases. In liquids, we have water, oils in the pipelines, the wastewater industries, okay, chemical industries, where there we can use them for the liquid flow rate measurement, and gases flow rate measurement, it can also be used. So in this video, we studied about the flow rate measuring device rotameter, which is also known as the variable area meter, because it measures the flow rate by measuring the change in the cross-sectional area around the float. Here we studied its construction, its principle of working, its advantages, disadvantages, and its applications. So I hope that this topic is now clear to you. Thank you.